All right, for today's warm-up, I want you to look at these two histograms here. These represent the student-to-teacher ratio or pupil-to-teacher ratio for the east of the Mississippi versus the west of the Mississippi. The first thing I want you to do is describe the shape of each distribution. So the west, what that distribution shape is, and then the east. The second question I want you to determine is which of these, the east or the west, has a better ratio. Think about what that word better means in the context of this problem and decide if it's better to be a pupil in the east or the west. All right, so first of all, the shape of the distribution for the west, what I always do is identify the highest bar, which is right here, right? And then think about how many are on each side. There's a lot on this side, only 2 on this side. So this one would be right skewed or skewed right, because the right side has a longer tail. So whatever side, find the biggest one, whatever side has more, it's that one skewed. The next one, the middle one, is right here, right? The highest one. And notice there's 1, 2, 3 on either side, and they're decreasing as they go down. This side does go down, this side goes down a little bit more. But overall, we would say this is symmetric, or I might even say approximately symmetric. Not exactly symmetric, but approximately symmetric. All right, and then does the east or west have a better ratio? So in terms of student-to-teacher ratio, or pupil-to-teacher ratio, lower is better, right? Lower equals better. Because if you have less students per each teacher, that means you get more one-on-one help. So if we look at these, the west, it looks like so the middle, if you had to sort of identify the middle of this one, there is definitely a lot at the beginning here, but the middle would probably fall maybe somewhere in here because we got more values here, right? And then less here, but maybe in the 16 range there would probably be the middle of that data. And if we're looking for the east, well, the middle would definitely fall, somewhere between these two bars because it's more on this side, less on this side. So at most, the middle is going to fall right here in about the 15 range, right? And you can see there's a lot more to the left of that one than there's on this one. So overall, and you can see this doesn't even go past 19 here. This one goes all the way up to 22. So definitely you would say that the east has a lower student or pupil to teacher ratio. East would be better. All right, today we're going to talk about 2 other types of graphs. We've covered histograms, bar graphs, Pareto charts. Today we're going to look at circle graphs and time series graphs. Other words for this would be a pie chart and a line graph. So first one we'll talk about here is the circle graph or pie chart. That's going to display our data in wedges of a circle. And this is a good visual representation of the percentage of the population. So if I took a survey, I said favorite type of pizza, I had pepperoni, cheese, veggie, meat, whatever. And I took a survey, found the percentage that preferred each category. That would go well into a circle graph. So this is best for qualitative data. Remember, that's categorical. So again, like favorite type of pizza, favorite color. What the example we're going to do is your home school. So whether you go to Newark or Heath or Granville or Utica, whatever, those would be categorical variables. In general, we're limited to about 10 or fewer categories for this. You could do more, but then your pie graph gets a little bit congested, a little bit hard to see. So about 10 or fewer categories is normally good. As always, we want to include a title. We want to label our data, so each of the wedge should have a label and also the percentage that goes with that data category as well. All right, and then to do this, in years past, we would actually draw these out by hand, and you would need a protractor, and you're going to find like the degree measurements and all that stuff. Since I can't really give you a protractor right now, we're not going to do that. We are going to be using our Excel spreadsheet as well instead of that. But you still need to know how to make this table. So this is going to be our table, which you would use for creating a circle graph. We're still going to do these steps. It's just that we're not going to be able to draw it because I can't give you guys a protractor, and you might also have to print out circles. So we're going to skip that part of it, but we are still going to do this table as a part of the circle graph. So in this table, you're going to have 4 columns. You're going to put the category. So whether that be like cheese, pepperoni, whatever. So let's just example here. So let's say pepperoni, cheese, veggie, and meat. Those are your 4 options. Put that there. The frequency, so maybe 7 people wanted pepperoni, 3 people like cheese, 2 like veggie, and 5 like meat. We would calculate a percentage next. So we're going to do the frequency divided by the total. So in this case, we've got 17. So this would be 7 over 17. And you're just going to compute this as a percentage. So that is 0.41, let's round it there, which equals 41%. And then now to compute the number of degrees, we're going to take the percent as a decimal, 0.41, and think about how many degrees are in a circle. Hopefully you remember there's 360 degrees in a circle. So we're going to take the percent as a decimal and multiply it by 360. And that gives you 148.2 degrees. So if we were to actually draw out a pie chart, you would start with something like this, and then you would take your protractor to 148 degrees, which would maybe be somewhere over here, and that's how you would draw your line. Again, we're not going to do that, but I still want you to calculate these percentages and the degrees. So then for cheese, we would do 3 over 17. That gives you 17.6, sorry, 0.176, which is 17.6%. And then we would do 0.176 times 360, calculate our degrees. And you would do this for all of your categories. So this would be 63.4 approximately. So then you would go from this line, 63.4 degrees, over here for your next one. So that would be how you would do that. Again, we're going to do this table, but we're going to be doing it on Google Sheets instead. So let's go ahead and flip to that real quick. And the data that we're going to use is from the 5th and 6th period stats class. I went through and identified your home schools. So we had 5 people from Utica, 8 from Lincoln Valley, 4 from Newark, 1 Heights, 4 Lakewood, 1 Northridge, 1 Heath, 1 Watkins, 1 Granville, and 1 Newark Catholic. So I've just went through and went ahead and did that. You'll be given some data, and you can just make a chart just like we did on the last assignment. And then you need to compute the percentage. In this case, I believe there's 27. Let me add them real quick here. Yeah, 27 students total. So you could even go ahead and write 27 if you want to. I'm going to show you some other shortcuts on how to do this as well. So you could write 27. Now, there's another way. I'm going to show you some cool formulas today that you can use. You can use, if you want to use a formula, you're just going to hit the equal sign. And then you can actually see the one that actually came up here, which was sum. I'm going to type it out, sum. And then you can just select a range, and it actually gives you a good suggestion there. And it just finds the sum of those and computes it. So 27. So if I were to change, like say Northridge, I change that to 5, and it's going to automatically update that. You can see it changed down here. So there's a lot of cool formulas you can do on Google Sheets and Excel. I'm going to show you how to do all of those for these. You don't necessarily have to do it. You can do all the calculations by hand, but it is nice to know how to do some of these formulas. So the next one is a percentage. So for percentage, using a formula, if you remember, you do the frequency. So I'm going to do this. I'm going to just click on this box because this is where my frequency is. So that's B2, that represents the row in the column. And then I want to divide that by the total number of values, which in this case is 27. So you could type out 27, or what you could also do is select this box because it already has the number 27. And then we're going to enter that. Oops. All right, so that should calculate it. My enter button doesn't work so well. All right, so there we go. That's my percentage as a decimal. Now what I could also do is go ahead and times this by 100. So asterisk 100, and that will convert it to a percentage. But if you want to do that, you can. So 18.51%. And then so there's my formula, which I computed for the first one. I just did the frequency divided by the total, and then times it by 100. So what I'm going to do is, I have it selected, you can click here, and you drag it down. I'm going to drag it all the way down to here. And, oops. Might need to actually just change that to the number 27. And then drag it down. Sorry about that. All right. So it's going to move the boxes down, so we'll work there. All right. So what I did is just create the formula, B3 divided by 27. And I dragged it down, and it just automatically computes that for all of them here. As you can see there. It just applies that formula. So on this one, it's doing B2 divided by 27 times 100. The next one here is doing B3. It just automatically drops down to the next box. Divided by 27 times 100. The next one, B4 divided by 27 times 100. So it's doing all the calculations for me. All right, and then, so again, I couldn't use this box because when I did it for this formula, instead of putting in 27, if I put the B12, then it actually goes down one box for each one, so it didn't work. So I just changed that to the number 27 there. And then you can see it applies it for all of them. All right, so next one, degrees, I'm going to do the same thing. You could do it by hand and just times it by 360, or what you can do is do equals, and then what I'm going to do is this one, C2, but since I turned it to a percentage, I'm going to go ahead and divide it by 100 to get it back to a decimal, and then I'm going to multiply it by 360. And that calculates my degrees. So I did the percentage. I just went ahead and divided it by 100 to get rid of this times 100. So it converts it back to a decimal, and then times it by 360. Then I'm just going to drag it down, and it's going to automatically compute all these degrees. So I've got my percentage and my degrees, which I just used a math formula for. Again, you could do these by hand if you want to. If you want to do the percentage as just 5 divided by 27 times it by 100, then type it in. And then for the degrees, you take whatever the decimal is as percent as decimal, multiply by 360. Or if you want to try these formulas out, they are useful, and you might need to use them in college or some other application of life. So it's fun to mess around with these formulas, and you can do some neat stuff with Google Sheets that can save you a lot of time. All right, so we've got our percentage and our degrees and our frequency there, along with our homeschools. Next, we're going to go ahead and create our chart. You actually don't need the percentage and the degrees in order to create the chart on here, but again, I want you to know how to do it, so I want you to do both. For our circle graph, we're going to highlight these two columns, the homeschool and the frequency, and then we're going to go to Insert and Chart. And we do not want a column chart. We want a circle graph. And you can see there, it does all of our percentages for us. We could actually see if they match up though. Whoops. Trying to move this over a little bit. All right. So first one was Utica. It says that percentage should be 18.5%. Looks, did it well. Licking Valley, 29.6%. Good. So you could verify all these, Newark, and you can see all of our pie slices there. The only thing that I would want to change is the title. We don't want to call it frequency. We could call this homeschools for 5th/6th period. And I'm going to center it. There we go. And that's a pretty good circle graph. A lot faster and a lot neater than you can actually draw on your own. But again, I do want you to do this table along with it. So don't skip this part. Make sure you can make the table. And then again, when you do the circle graph, you just highlight the first two columns. All right. And feel free to try the formulas. You don't have to, though. Well, let's go ahead and look at our second type. Here's some more examples here of circle graphs. The next type is called the time series graph. Time series graph, or a line graph, you might have heard it called that in the past. It displays data in order of occurrence at irregular intervals over a period of time. So obviously a time series graph, we're going to be talking about time. One key thing here is regular intervals. So you can't have an interval go by months and then switch to years and then the days. It has to be regular, even intervals over that period of time. Make sure you include titles and label both axes, as with any graph. And the time always goes on the horizontal or the x-axis. Time always goes on that axis. Here's a couple examples. Here's some company sales from the year 86 to 2000. Here's another one. This one is the population of Ireland and overall Europe over a series of years. So the one that we're going to make, some data that I got here, is the average high temperatures for the city of Columbus for any given year. So I just went to this website here, got the months and the average high temperature, January, February, March, April, May. There isn't a lot else we need to do with this. There's no other calculations or anything. So all we're going to do is highlight these two columns, and then we're going to insert chart, and it actually gives us the one that we want, a time series graph. Already pretty good there. Just double check all the axes that they're labeled. Yep, month, average high, and Fahrenheit. We got the months here as well. Let's change the title to average high temp in Columbus. And let's put Fahrenheit. And that's about all there is to it. Maybe you want to add some more lines on the horizontal axis or something. Let's do that. So let's add some, I don't know if we can add more stuff. Grid lines and ticks. There we go. So let's add some more of those. The horizontal axis, major ticks. So maybe it's a little easier to tell there. You can make them longer if you want to. So mess around with some of those. Make it look pretty, but that is all there is to it. So those are our two new graphs, circle graphs, time series graphs. Neither of them are too difficult, but if you are struggling with how to plot these on Google Sheets, make sure that you do reach out to me. All right, we'll see you guys later.